Here is a question on vector application. Velocity is a very important topic, and so we have number of examples where we have velocity and displacement in an environment which is sometimes is fluid most of the time, sometimes in water and sometimes in air, right? So this example is a supply boat needs to cross a river from point A to point B. Point B is on the other side of the river from point A, 1.5 kilometers downstream. The boat can travel at the speed of 20 kilometers per hour in still water. The current is flowing at 12 kilometers per hour. The width of the river is 500 meters. Determine at what angle to the bank the captain should steer to cross the river to B. Okay, so that's the question. So any word problem given to you, my recommendation is read it twice. Now next time when you read it, then try to sketch your model which could represent the situation, right? So let's read it once again. I already have a sketch for you. So we call them velocity diagram or displacement diagram, depending on whether we are showing velocity or displacement. Well, one more thing is, displacement is directly proportional to the velocity. Higher the speed, more the distance covered, correct? So in a way, both are represented by or can be represented by same diagram. So in most of the examples, I'm just drawing one diagram. Sometimes when I have to explain, I'll split them in two. Okay, let's read the question and understand our figure. A supply boat needs to cross a river from point A to point B. Point B is on the other side of the river from A, 1.5 kilometers downstream. That means if we have this river here, then, so this is our river. This is our river going downwards, correct? Point A is on this side and B is on the other side 1.5 kilometers down. Do you see that? So it is A and B is 1.5. So I've written 1.5 kilometers down for B, which is on the opposite side. Do you see that? Yeah. The boat can travel at a speed of 20 kilometers per hour in still water. The current is flowing at 12 kilometers per hour. The width of the river is 500. That means from here to here it is 500. So in kilometers, 0.5 kilometers. Determine at what angle to the bank the captain should steer to cross the river to B. So if the boat is trying to travel somewhere here, then water is going to push it further down. So the captain should steer it at a higher point than B, right? Somewhere between these two. Now we don't know where that point is, so let it be C. So we say, well, let the captain steer the boat towards C, and then water is going to push it with a velocity of 12 kilometers per hour down to B. So we have to figure out location of this C, point C, or the angle at which the boat is being steered. So that is what the question is. Determine at what angle to the bank the captain should steer to cross the river to B. So that is the bank and the angle with the bank. That means in this diagram, theta plus alpha, both added together gives you the angle for the boat to be steered, right? So I think the diagram is self-explanatory. A to C represents here the velocity of the boat. And I've written 20 times t and converted them to displacement. So now A to C represents displacement 20 times t, right? In 1 hour, the boat will cover 20 kilometers. Do you see that? That's the whole idea. T is what? 20 kilometers. So that's the idea. And water will push it 12 kilometers down. Think like this. So we wrote T here. So if I don't write T, it becomes velocity vector diagram. If I write T, it becomes displacement vector diagram. So they are apparently the same. Basically we get two similar triangles, right? So when the triangles are similar, angles will be exactly same, and therefore the strategy is to find the angle and use them in both the triangles, same angles, right? That is the strategy. Now let's solve it. Now as you know, point A and B are on the other side of the bank. Width of the river is 0.5 kilometers. So we know this side is 0.5 kilometers. And point B is horizontally down 1.5 kilometers. So that helps to find angle theta, right? So tan of theta should help us to find theta. So tan theta is opposite over adjacent. That means 0.5 over 1.5, correct? So that gives us the value of theta. So we say theta equals to tan inverse of 0.5 over 1.5. So we can use our calculator and find the inverse. So we get second function tan inverse within bracket 0.5 divided by 1.5 bracket close equal to 18.43. So we get our theta value as 18.4349, right? So let's say theta is 18. Let's round it to 18 this time. Okay, let's say 80 degrees. I know this is going to give us huge approximation, right? So we will write 18 later, but in our calculations we will use 18.4349. So I'll write 435 degrees. In calculation it makes huge difference, right? So we should use 4 decimal places to calculate our answers. Okay. Now, so that is the angle, which is this angle, right? Now, once we know this angle, then we can actually find the other angle. These two lines are parallel. Do you see? These two lines are parallel. They are horizontal lines, correct? So, since these lines are parallel, this theta angle is also equal to this theta angle. So now in our triangle, we know this angle theta. We also know the two sides. Therefore, we can use sine law and find angle alpha, correct? So that is the strategy for us. So we say sine alpha over the opposite side, which is 12, right? So we can write 12t here, or we could also write 12 because velocity and displacement are proportional, right? But anyway, we'll write 12t this time and see what happens, right? So we get sine alpha over 12t. 12t, why? Because the velocity of water is 12 and time taken, we are just saying t, so that we make it a displacement vector graph. We are putting all of the displacements. That is why. So we are writing 12t opposite to alpha, right? 12t. That should be equals to sine of theta. So we write sine of, so instead of 18 degrees, I will write 18.435 just for accuracy. Divided by side opposite to it is the boat speed 20t. Correct? Now from here we can find what alpha is. So sine alpha will be 12t times this, right? Let me write sine alpha equals to 12t divided by 20t times sine of 18.435. Now you will appreciate what I was trying to say. T and t cancel out. Do you see? So either we work with velocity triangle or with displacement, the result is same. Do you understand? That's the beauty. So that is why in most of the examples you will see that we sometimes interchange. We don't really write 12t, we'll write 12 here and 20 here, and we'll call that as a velocity vector graph, correct? So that is how it is to be seen, right? Now let's calculate this. So we can use our calculator and find alpha. So what is alpha equals to? Alpha equals to sine inverse of 12 divided by 20 sine of 18.435. Correct? So we'll we'll do sine of the angle times 12 divided by 20. So we get this, and we do sine inverse of this function, right? And get our answer, which is 10.9374. So that is what we get, 10.9374. Let me write 10.9374. So this I will approximate to 11 degrees, correct? That's a good approximation. So alpha is 11 degrees for us. So we get this angle alpha as 11 degrees. And we already have theta as 18 degrees, right? And therefore, what is the total angle? So total angle will be this plus this, correct? So we can add them up. And we get angle of steering is equals to, let's say angle of steering is phi, which will be equals to 11 plus 18 degrees, which is 29 degrees. Do you understand? So that becomes the angle to the bank. So with the bank, this is the bank, our boat is making an angle of 29 degrees, right? This is it. So what I have also done here, so this was a velocity, this is the velocity diagram which I have shown you down here. This is, initially we were working with displacement diagram, correct? So that I will call displacement diagram, since we had multiplied by t, right? Now here I have repeated the same diagram just to show you that it is exactly the same, and I'm calling this as velocity diagram. So AC here is shown by 20 kilometers per hour. Do you see that? And water velocity, river velocity, is 12 kilometers per hour. Angles are exactly the same. Do you see that? And therefore we'll get the same answer, that the boat is steered at an angle of 29 degrees with the bank, right? So that is how we are going to do it. I hope you appreciate that both velocity and displacement diagrams will actually give us the same result, since they are representing similar triangles, and in similar triangles angles are equal, correct? I hope you loved this solution, and moving further, it will be easy for you to do any question on velocity when we are dealing with vectors. All the best.